With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is, which of the following lines correctly show the temperature dependence of equilibrium constant K for an exothermic reaction? Options are C and D, A and D, A and B, or B and C. So we are given here a graph, you can say, representing A, B, C and D lines, and we have to tell which of these lines correctly show the temperature dependence of equilibrium constant for an exothermic reaction, right? So first of all, we know the relation between delta G, that is the Gibbs free energy, is equals to delta G naught, which is the Gibbs free energy at standard conditions, plus RT natural log of Q. So Q is the reaction quotient here, R is the gas constant, and T is the temperature, right? Now, if I take a reaction that is A plus B gives C plus D. So this reaction, if we talk about this reaction quotient, that is QC, that is reaction quotient at concentration C. So it will be the ratio of products, that is C, divided by the reactants, that is A and B, right? Also this we see for Kc. So Kc is the equilibrium constant at concentration C, which is also equals to the product of ratio of products upon the ratio of reactants. Kc is equals to the ratio of products and the reactants, right? So now this values we can see are similar. So if the equation is undergoing, like the equation has a condition of equilibrium, so Kc will be considered, and if the equation is at any temperature, or you can say concentration, so it will be at Qc, that is the reaction quotient is this, right? So if we can write it as here as at equilibrium Qc is equals to Kc, right? Now if we see in this particular case, so as we know, at equilibrium Gibbs free energy is equals to 0. So if we put Gibbs free energy, that is delta G is equals to 0. So this reaction becomes delta G naught is equals to minus RT natural log of K, because quotient is equals to Kc as at equilibrium, right? Also we know that also delta G naught is equals to delta H naught, that is change in enthalpy, minus T delta S naught, that is temperature, and change in delta S naught is entropy, right? Now, if we equate these two equations, so it will be therefore minus RT natural log of K is equals to delta H naught minus T delta S naught. So this equation will become natural log of K is equals to minus delta H naught upon R into 1 by T plus delta S naught upon R, right? Now this particular equation is compared to the equation of a graph, straight line graph, that is y is equal to mx plus c, right? Now m is the slope and c is the intercept here, right? So slope defines this value, the value of delta H naught, and intercept is delta S naught upon my R. So if like now that basically the slope value depends, the slope depends on the value of delta H naught, that is change in enthalpy. So the negative sign is here, right? So it does not mean that the slope is always negative, but if the value of delta H naught is positive, so the slope will be negative. Now we'll define the slopes of the two reactions. So first of all, we'll take the case of endothermic reaction. For endothermic, so in endothermic reaction, so basically in the endothermic the heat is absorbed, so delta H positive is in this case, so the slope will be negative. So if I draw the graph for this case, so the graph will be like here ln k versus 1 by t. So the graph will be negative in this case, and a straight line will be drawn like this. Also this value, if we see that this intercept value here is the intercept value, so this intercept value here is in positive, that is delta S naught upon R value is positive. But if delta S naught R value is negative, so the slope will be here. So the intercept value will be negative for this slope, that is delta S naught R value will be negative, right? And if we talk about the other case, that is for exothermic reaction, so delta H naught, that is exothermic, the heat will be evolved, so it will be negative, and the slope will be positive, because if we see that if delta H value is negative, so negative will be positive and slope will be positive. So the graph for this case ln k versus 1 by t. So the graph for this will be a positive slope, so the straight line slope will be like this, and this intercept will be a positive value if delta S value S naught upon R value is positive in this case. And if it is negative, the slope will be in the negative side, so this will be like this. This value, the delta S naught upon R value will be negative for this slope. So if I give this straight line A and this is B, right? So this is the graph for exothermic reaction, and the values basically depend on the delta S naught, right? So the two straight lines representing the lines which show the temperature dependence of equilibrium constant K for exothermic reaction is A and B, right? So A and B is the correct answer, that is third option.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.